Hello friends, in today's class we are going to talk about another scheduling policy called highest response time next. So welcome here, and we are talking about highest response time next, and this response time will be calculated as a ratio which is W, where W is the waiting time and S is what? S is your burst time. Okay, so this ratio will be calculated, and the process is having largest value of this will be scheduled first. If W is 0, then it will become S by S, and that will be definitely equal to 1. All processes must have a response ratio greater than 1. The mode of working here in this case is a non-preemptive. So this algorithm is a non-preemptive algorithm. To apply this, I have taken an example, and we are going to draw the Gantt chart for this, and let's see that how does it work. So now at P equal to 0, at T equal to 0, we have a process, only one process with us, which is P1. Okay, so P1 will be scheduled, and since it is non-preemptive, up to 3 it will run in this way. At instance of time, the only process that had arrived here in this case is P2, so there is nothing to choose, and because it is non-preemptive, up to 9 times the same thing will happen. If you consider the instance 9, then there is a P3 and there is a P4 and there is a P5 which arrived at 4, 6 and 8. Their waiting time will be what? 9 minus 4, right? 9 minus 4, and that will become 9 minus 4 is 5, 9 minus 6 is 3, and 9 minus 8 is waiting time. Their burst time is what? 4, 5 and 2, and their response ratio W plus S divided by S will be what? It will become 4 plus 5 divided by 4. This will become what? 3 plus 5 divided by 5, and it will be 1 plus 2 divided by 2. So this will become 9 by 4, and it will become 2.25. This will become 5 plus 3 8, 1 point I think 6, yes 1.6, and this will become 1.5. So among this process, we having the highest response ratio as P3, so we are going to schedule P3 here. The 9 plus 4 becomes 13, and scheduling will be done for P3. At 13, again we'll calculate the same thing, that for P4 and P5, right? Let me write here, P4 and P5, at 13, their waiting time will become what? So their waiting time, they arrived at 6 and 8. So their waiting time becomes 13 minus 6, which is 7. 13 minus 8, that is equal to 5. So 13 minus 6 is 7, and 13 minus 8 is equal to 5. Their burst time is same, and burst S is equal to 5 and 2. And if you calculate his 7 plus 5 divided by 7 plus 5 divided by 5, 7 plus 5 is 12 divided by 5, so that will become 1.4, isn't it? So 12, okay, 2.4, sorry, 2.4, yes, 2.4, and this will become what? Waiting time is 13, and 5 plus 2 divided by 2, and that will become 7 divided by 2, and that will become 3.5. So now we can see that here 13, the next process to be scheduled is P5, because its response ratio is higher, 3.5, and it will be scheduled for 2 times, and 13 and 2 it will become 15. And finally we have only one process left, which is P4, and that will be scheduled for 5, so P4, and that will become 20. Right? So this is your Gantt chart, and this is how does it work. This entire process I have summarized over here, that at T equal to 0 we have only one process available, T equal to 3 only one process available, scheduled. T equal to 9, 3 processes are there, C, D and E. C, D is having were available at 4, 6 and 8 units respectively. Therefore the waiting time is 5, 3 and 1, and using the formula 2.25, 1.6 and 1.5, C is having highest response ratio, gets scheduled. 13, we have two jobs, D and E, with the response ratio 2.4 and 3.5. So we select E for the so process E is selected for the next and D is selected last, right? So that is your scheduling policy, that is known as highest response ratio. Next, okay, so the next thing that we are going to learn is priority based scheduling, right? So that next part is your priority based scheduling. Thank you.